All right, I'm going to do a little bit of a homework demo here for homework 4, as this is definitely going to be a bit more challenging than anything you guys have taken on thus far. So I'm going to start out by just getting in my comments here and talking a little bit about what we talked about last night and why this works or doesn't work, and where we can go from there. So I'll call this week 4 demo, just like we did last night. The date today is actually 9/18. 2024. And option explicit is where we're going to start all of our micro basic script code. And just to remind you what we're dealing with, I'm going to show you the course that I'm going to try to navigate. So I'm not going to give you everything. This will be a challenging demo, but I will give you at a minimum, I will give you how to make this branch with the digital input, either go to the right or go to the left. And I will give you one stop point here. You may have to get a little bit creative on your Boolean logic. You may have to look into not just if then, but if then, else if, else if, else if. You may have multiple things that you're going to look into on this. So we'll go with that. So option explicit is what we're going with. I'm going to define my variables. So define in memory, throttle, as an integer. Apologize for the phone ringing there. I'll get back to them in a few minutes here. I'm going to define in memory steering as an integer. I'm going to define in memory p gain. So I'm going to give myself that multiplier for p gain. And again, I'll do that as an integer. And then I'm going to define in memory, I am going to use that stop bit. I think that's going to come in handy. So and maybe it will, maybe it won't, but I'm going to create it nonetheless. You'll notice if I just type in stop, stop is a reserved word. So I can't use stop as a variable because it's actually a command within microbasic, but I can use stop bit all day long. And this will be a Boolean. And then I've got a few more. Define in memory tape position as an integer. I'll define in memory left position. I can see I'm actually putting it on the last line here. Sometimes when I hit enter, it doesn't always work. Left position as an integer. I'll define in memory right position. Apparently got to hit enter twice. Right position as an integer. And then I'll define in memory right marker. You'll probably want to also define in memory left marker. I'm not going to give you everything though. Right marker is going to be a Boolean, so I'm going to define that as a Boolean. And then define in memory the digital input, so I'll call it din3 as Boolean. All right, so I think I have most of my variables defined. So throttle and steering, again, mixed mode 1, I'm going to work off of throttle and steering. P gain is going to be a multiplier that I can use to turn the wheel a little harder, turn the wheel a little less. Stop bit will be a bit that I can use to kind of signify that this is a stop. It's a bit I'll be able to turn on and turn off as needed when I want to go back to my normal throttle speeds. Tape position is the -50 to +50. Left position is just going to be my -50 to 0. It's going to be the left-hand side of the sensor. Right position is going to be the right half of the sensor. So that'll be the 0 to +50. The right marker is only going to be looking for reverse polarity strips on the right as a Boolean. And then my digital input 3, if I call that, I can determine if I want to turn left or right based upon a digital input. The next thing I'll do is I'll put throttle in here as a default value. So I've created the variable. Now I'm going to initialize that variable. I'm going to do p gain. And I'm going to set it equal to -2000. I just saw that worked good last night, so I'm just going to use it where I left it. And stop bit, I'm going to define that immediately as false. So basically, it's going to start out in the false case, and then I'll use it as I need to turn it on and off as time goes on. As always, I'm going to define my my code using the analogy that we use in the PLC world, which is the first thing in my scan cycle would be read inputs. The next thing in my scan cycle will be execute program. Then I will have diagnostics, and then I will have update outputs. You can call these anything you want. You don't have to use, my methodology. I like it because it kind of is in keeping with what we do in other courses around here. I'm gonna do a wait 10 milliseconds, so that'll give me a wait time. So basically, if I do wait 100, I would execute this loop 10 times a second. If I do wait 10, I'll execute this loop 100 times in a second, and then I'll go to top. All right, so that's just my controller. That's basically my scan cycle. Go read the inputs, come back. Execute the program, come back. Do my diagnostics, come back. Update my outputs, come back. Wait 10 milliseconds, and then go to the top and do it all over again. So now I actually have to define those subroutines. So I'm going to say read inputs. All right. I do need to do it with a colon. And what I'm going to do is I'm going to do tape position first. Tape position equals, and you can get these right out of the PowerPoint, but it equals get value. Parenthesis underscore MGT. And again, I'm just going to put a comment in here for the sake of myself here. This reads full sensor. From left to right, -50 to +50. The left position is going to be a little different. I'm going to equal the get value and underscore MGT, but this time I'm going to put a (1). And just for my sake, I'm just going to remind myself, this reads left half of the sensor. Then I'm going to go right position, equals get value, underscore MGT 2, and this will read the right half. I don't need to put that in capitals. Right half of sensor. So again, the left half would be my -50 to 0. My right half would be my 0 to +50. And the other inputs I want to read is I want to read that right marker. That's going to be equal to get value. And this one is, I got some notes over here. It's MGM. Instead of MGT, it's underscore MGM. And for the right marker, it's 2. For the left marker, it would be 1. And so this will read marker strip. That reverse polarity marker strip on right. If I wanted to read a reverse polarity marker strip on the left, I'd get value underscore MGM1. And then finally, I've got DIN3 as my other variable that I had. DIN3 is going to be equal to, similar to what we were doing before, get value, underscore, DIN, comma, 3. Since it's in this, so this will basically read digital input 3. So now I know what all of these things do. I'm going to read all my inputs. I can return at this point. Let me get a drink here real quick. Now I'm going to go into execute program. All right, when I execute my program, this is where it's going to get a little tricky. Some of the easy stuff I can do is I can, I'll do my steering in here. I'll do all of that type of stuff. But I'm going to start off with what happens if the digital input's on. So if the digital input's on, I want to use the left portion of the sensor to track. If the digital input's not on, I want to use the right portion. The reason being is when this guy goes, what you're going to see is he's going to get to a point here, and he's going to be seeing things on both sides of that sensor. You can see it right there. where you're seeing things on both sides of the sensor. Now I'm running my code right now, so bear with me. I've already got the code executing here. But if I want to track the left side, I need to just be reading the left half right now. So if the digital input 3 is on, read the left half. If the digital input 3 is not on, read the right half, because I would be following either the dot on the right or the dot on the left, and I would track the fork in the direction I want to track. So what I'm going to do is I'm going to start off with that. I'm going to say if DIN3 equals true. Okay, so this is going to be a conditional statement. So it's going to be an if then. I'm actually going to put a little bit of a space in between here. If digital input 3 equals true, then what I'm going to say is tape position equals left position. Tape position equals left position. And I'm good. Else, tape position, got big fingers today, hit the caps locks a couple times there. Tape position equals right position. And then you always, anytime you're using the if statements, if then, else if, we always end with the end if, and there needs to be a little space in there is all it needs to have there. All right, so if digital input 3 is true, then look at the left half of the sensor. Otherwise, look at the right half of the sensor. So that's one conditional statement that I can see. And so I could say, I could put a comment over here that this is, fork tracking. Which way am I going to go fork, or maybe fork track, direction. Fork direction, which is going to be based upon that digital input. All right. Then the next thing I'm going to do is I'm going to, because I think it's easy to do at this point, I'm going to go ahead and put in my steering command. So I'm going to say steering equals, and this is something we've done on a bunch of these at this point, so we don't have to be real picky at this point, right? I'll do tape position times P gain, okay, whatever that is, divided by 1,000. So again, we're working with integers, so I've made my P gain 1,000. I'm going to divide that back out so my multiplier isn't a huge number. But now I've got a steering command here. And I'm going to return. I've not addressed the pauses right now. I'll address those in a minute, I think. But for right now, I'm just going to address, let's get this thing steering left or right, make sure that works, which I think it will because we had that working fine last night. And then diagnostics will be my next area on here. I'm going to go really fast just because I don't want the video to be 2 hours long, but you guys can obviously rewind this, watch this over and over again, pause it, kind of code along with me if you like, and make this work for yourself. So my diagnostics is going to be real simple. Print. Basically, my diagnostics is I'm going to print to that debug window for the purpose of using that debug window kind of like a multimeter. I want to know what left position is. Equals space. The quotes is the text that it's going to put on the debug window. And then this is the variable I want to print with it. So left position equals left position. What that's going to do is it's basically going to tell me, oh, here's what I'm actually reading, right? I'm not going to put right position on here right now. I could put, well, I could. I'll do it. Right position. Again, I'll put a quote. Always nice to have that space at the front and after the equal sign, so you're not just smashing this thing together. You're actually, it says right position equals, has a space, then it puts the number that it's getting out of the variable. So now I've got right position. I'm going to go to the right a little bit because I do want to get that digital input status as well. So then finally, I'm going to get DIN3 equals space, quotation, and then I'm going to read what's in DIN3. And again, this will be my one Boolean version that I'm going to have coming into my debug window there, or my console. And then the last thing I always like to include is the /R for the carriage return, because what that does is it ensures that I'm going to bounce down to the next line and not just smash this thing all together. So basically it'll print this all across one line and then go down the next line and print it all again. So real nice way to debug and be able to use those as kind of like a meter to kind of see where the variables are at. The last thing I'm going to do, pretty simple and easy here, is I'm going to update the outputs. Update outputs, colon, and then I'm going to set command, and I'll go underscore, G comma 1, and this will be throttle. Again, in mixed mode 1. In mixed mode 1, channel 1 is throttle and channel 2 is steering. In separate, channel 1 would be the left motor and channel 2 would be the right motor. G2, this will be steering, and then I'll return. So now I should have enough to, at a minimum right now, I should be able to determine if I'm going to go left or right based upon the digital input. I should be able to steer, and I should have these things printing to the console. So I'm going to copy this real quick. I'm going to go back into the AGV sim. I'm going to paste that code in here, overwrite what's in here right now, and I'm going to run this thing. And what you'll see is what it's doing is it says right position is, or excuse me, DIN 3 is false. So it should go to the right-hand side. Works like a champ. If I hit reset, I turn digital input 3 on by just selecting the digital input in the simulator. I go to run again. Now you'll see down in the console down there, digital input 3 is true, and it should track the left position. So at a minimum, everybody in the class should be able to do the fork detection and make sense of what's going on there. Now we got to deal with marker strips. I'm not going to give away all the marker strip homework advice to you in here, but you will be able to use and come up with the marker strip stuff that you need to. So what I'm going to do real quick is I'm going to go ahead and go into here and go back into the code, and I'm going to write in some marker strip here. So if digital input 3 is I'm doing this, I don't have anything in here for marker strips, so I'm just going to kind of plug it in here and say if I see and the only marker strip I have right now is I have the right marker. So if right marker goes true, I want to do something. So I'm going to plug it in underneath. I got digital input 3 here I'm doing for fork detection. I'm going to do another if statement here. If right marker equals true, again, we need a then. If right marker equals true, then, and instead of setting throttle and steering to 0, what I'm going to do is I'm going to take control of the motors completely, and then I'm going to wait and then come off of it and then go again. So what I'm going to do is kind of similar to what I did down here with the set commands. What I'm going to do is I'm going to say if right marker is true, I'm going to set command G1 to a 0, and I'm going to set command G2 to a 0. And then I'm going to wait. And I'm going to wait. And the waits for the homework aren't critical. I don't care if you wait. I want to see that it actually comes to a stop. So I'm not going to sit there because depending on your looping wait, it may be real time, it may not be real time. I want to see that it stops and waits. That's really what I'm up to. So I'm going to wait 1,000 or 1 second, and then I'm going to do another set command, and I'm basically going to drive off that strip. So just to kind of go over what's going on here, and to make sure I get off that strip, I'm going to wait 2,000. What I think that's going to do is, again, I'm going to take my throttle back to 250 now. So basically, when the right marker is true, stop and wait is what's happening. When the right marker is true. Once I've waited, I actually put it down here. So this is my stop and wait. Once I've waited sufficiently, then what I'm going to do is I'm going to drive off that strip. The nice thing about this is what we're not doing is we're not having conflicting commands with the throttle and steering commands. We're just staying within this condition right now. If the right marker is true, stop the motor, stop the steering, wait a second. Then turn the throttle on, drive straight, wait 2 seconds. That's going to give you sufficient time to leave that marker strip, right? And then I'm going to go into my else condition. And my else condition is going to be really, really simple. It's going to be else I'm going to set my commands based upon throttle and steering. So I'm going to go back to whatever my normal throttle and steering commands are, because now I actually am concerned about the steering, not driving off the strip, and I want to go back to my normal 250, which this got me to my normal 250, but I think this will actually work even better. And then I want to end in the if statement there. So what this does is go back to normal navigation. Now what's interesting, if this works, we didn't actually use the stop bit. So, and I think it'll work because if the right marker is true, stop, wait a second, and then start driving with 0 steering, wait 2000. So that drive command at 250 RPM is going to get me clear of that strip. Once that 2000 wait is expired, I'm going to go back to my normal throttle and steering. So the one thing that's interesting is I'm not actually steering right here. I could probably make this steering if I wanted to. We could try that, but I'm not too concerned about it because I'm just going to drive straight. I believe we have everything in here to make this functional. So I'm going to grab this whole thing, go back into RoboRun, into AGV Sim, paste all this into here. I'm going to compile it. Again, I'm going to make sure that this builds. I have no errors, no warnings. Again, if I had an error or warning, you might see something like, if like this then statement wasn't here, right? If I compile now, actually it didn't give me an error. That's kind of weird. Let me give you something that for sure is going to error out here. If I don't have this end if statement here, that'll for sure end out. So what it's saying is okay, line 69, unexpected into file. It won't always tell me what's going on because what's happening is it's seeing this conditional statement and it doesn't see an end if anywhere in the program. So it's saying, I'm in this conditional statement, but I didn't see an end if. So it thinks the whole thing is part of this if statement. So it doesn't always tell you exactly where the error is or exactly what the error is, but it will try to point you in the right direction at least. Or if instead of steering, if I say steer in and I build it, all it says use of undeclared identifier steer in, line 58. If I go to line 58, it's telling me, hey, I don't know what this is. Well, that's because we don't have a variable called steer in. We got a variable called steering. So pay attention to the compiler. It does give you advice on where the fault is. Sometimes it's very helpful, sometimes it's not, but it's at least going to get you in the right ballpark as to where this is. So now if I hit go, I'm going to turn digital input 3 on. I'm going to hit go. Digital input 3 is true. I should follow the left half of the fork. I'm going to track on the left side. Now when that right marker goes true, I should see this device or this AGV come to a stop. The AGV comes to a stop. It's going to wait about a second. So 1,000. But in real time, it's not a second. In real time, it could be a couple seconds. Now it's going to drive off at 250 RPM. And then once it's to 2 seconds, it's going to resume normal navigation. I might have made that a little long, but it looks like it worked. The one thing I probably would adjust is that weight right there of the 2,000, which is right here. I might make that down to 1,000 because we're off the strip long before then. And now when I run it, it should, again, it'll wait a period of time. And then once it drives off, I'm going to go back to normal navigation. This time I didn't do my digital input 3, so it's taking the bottom track, but I should see the exact same thing. Now, when you guys do this, you're going to need right markers, left markers, and there may be times, like when you look at the charging station over there, where the charging station, you're going to look for both. If left marker and right marker is true, then do this. Else if left marker is true, do this. Else if right marker is true, do this. Else do this. So you've got a lot of different things that can occur in this particular homework. I've given you enough of the tools in your toolbox right now that if all you did was get this much of it working, you're going to do well. You may need to tweak some things, right? You may need to, instead of driving straight with zero steering, you may want to drive straight with your steering command. You're going to have to figure out how to, get in this nested else if statement. If left marker and right marker are true, then this. Else if this, else if this, else if this, else if this, and if. Actually, the last statement would be an else. The else is the catch-all, and then and if. So you can see I'm actually stopped here on a right marker, and I'm actually going to drive off. So that's another right marker. But remember, we have a speed up, slow down. What I will tell you on the speed up, slow down is, and you'll notice because that right marker is true, is longer, it stopped twice on there because it didn't drive off. So maybe that 1500 isn't good enough, right? Maybe I want to, or that 1000 isn't good enough. Maybe I want a 1500 weight so I can get off of that strip. I'm going to leave all of that up to you. You might also want to change the 0 to a steering instead of a 0. So you continue to track with the strip. All of that's going to be left up to you, but I think this video is really going to help you guys take a giant leap ahead. If all you do is this video, I'm pretty much guaranteeing you're getting 80% on the homework. But I want you to try to get as many of those details into your program as possible. So hopefully that helps. Again, reach out to me if you have any questions on the homework, and we'll see you next week.